In this next example, we're going to look at a secant graph. This one has a vertical shift, as I'm just quickly looking at it. Vertical shift, it's got a reflection, it's got some phase shift period stuff going on, so we've got a lot to deal with in this one. Again, I think the best approach is to consider the graph of the cosine, because the cosine is the reciprocal of the secant, and then we incorporate the graph of the secant from there. So first of all, I'm going to design this graph, or design my 5 key points based upon what it would look like if I was looking at 4 minus the cosine of pi x plus pi. Look at that graph first, and then we can work with the secant graph. Okay, so let's go through and get our 5 key points, figure out a period, all that stuff. So the period is going to be 2 pi over b. Well, remember, I should probably factor this first, and it doesn't matter which one I'm working with. If you look at pi x plus pi, remember when we factor these, in order to get the phase shift and the period figured out, we want to pull out whatever the coefficient of x is. So if I factor out, in this case, a pi, that would leave me with an x plus 1. Okay? So my b value is pi, the phase shift is, well, this is a plus 1, so the phase shift is the opposite sign, it's left 1. So my period is going to be 2 pi over pi. The pi's cancel, and that gives me a period of 2. Okay? The phase shift, again, is the opposite of the sign of what's in the parentheses there, so it would be a negative 1 or a left 1. Okay? Then we have an amplitude change. Oh, no, we don't. Nope, we have a vertical shift. I don't know. What am I looking at there? Vertical shift. The vertical shift is up 4. Okay, so that's a positive value. And then we're subtracting the secant, so that's a negative coefficient on the secant, which creates a vertical reflection. Okay, so there's a vertical reflection on this graph. All right, but the amplitude is 1 because it's the absolute value of that coefficient. So amplitude is just your 1. Okay, so let's go ahead and we'll plot the graph of the cosine. Oh no, I can't do that yet. Jumping ahead of myself. We got to get our 5 key points in. The 5 key points, we're going to start on the left. Well, because there's a phase shift of -1, we're going to start at -1. There's a period of 2. So if you go from -1, you go out 2 units, that'd put you at 1. This is actually going to work out nicely because I don't have any pi's on the x-axis. My divisions are all whole numbers, or integers, I should say, integers. And -1 to 1, that's going to be a pretty simple interval to chop up. So halfway in between is 0, halfway over here is -1/2, and halfway to the right is +1/2. So those are my 5 key points: -1, -1/2, 0, 1/2, and 1. Okay, so now I'm going to start to sketch the graph of the cosine, get the axes set up. And this is straddling 0, so I want my y-axis sort of in the center of the graph, actually. And actually, the other thing is, before I draw my x-axis in, we have a vertical shift of 4 units up. So I want my x-axis to be kind of low on the graph here. Yeah, something like that. Okay. And then I've got to put these points in. So we'll have -1, -1/2, we'll have 1/2, and 1, and of course we could go a little further. We could put 3/2 in there. We could put -3/2 in there if we like, just to give a little bit of extra space. Again, the vertical shift is up 4, so what I would actually do is draw kind of a dashed line through at 4. just so that I know where the middle of my graph is vertically. So let's go, actually, because that's 4, let's double it for the top of this axis. Let's go up to 8. That way this puts 4 kind of in the center, roughly, of the graph. And I'll chop this down to get all my other points. So there's 1 through 8 on the vertical axis. Yeah, I'll throw -1 on there just to fill in some space. Then put my dashed line across at 4. So that's my sort of the middle axis of the graph. Okay, it's going to be going around that axis. Okay, so the cosine, if we look at the cosine graph first, it's going to start, remember the cosine starts high and goes down and then comes back up. We want to start it high at -1. And the high value, think about it, an amplitude of 1 from 4 goes up to 5 and down to 3. Okay, so at -1, we want to start up at 5. Okay. Then at -1/2, we go up, we go to the axis right there. Again, this is a cosine graph. Then it's going to come down to the minimum at the halfway point, so that's at 3. Then it's going to go back up to that middle axis at 1/2, and then up to the max at 1. All right, so hopefully that looks decent. Then I would plot, let me get rid of all these markings I used to sketch those out. Okay, now we draw in our curve. There they are. Okay, now remember, wherever there was an x-intercept on the cosine, there would be a vertical asymptote in the secant. Well, the x-intercepts, quote-unquote x-intercepts, are actually the horizontal sort of axis there. Not the x-axis, but the center axis of the graph. And so at -1/2 and at +1/2, we would have vertical asymptotes for the secant graph. Okay, so I want to sketch in those asymptotes. At -1/2 and at 1/2. Okay, so I've got my 2 vertical asymptotes in there. And then the graph, let's see, am I missing anything else? Oh, there's one other thing that's very important here, and I missed it when I plotted that graph. Ugh. It's the, where is it? The vertical reflection. Missed the vertical reflection. So we don't want the cosine to actually start up, we want it to start down. I missed that. So let me replot that. Oops. So I did graph the cosine correctly, just not the negative cosine. So we should graph the negative cosine. So it's going to be flipped upside down from there. So instead of starting up at 1, it's actually, or at 5, it's starting down at 3. Wipe that off. Goes up to 5. See, even your instructor can make a mistake. And then it goes down to 3 at the end. Over there. Okay, so it's going to be kind of an upside down cosine. Good thing I caught that. All right. Now, how many of you noticed that when I was plotting it is a question. Okay, so let's sketch that in. And we have our vertically reflected cosine graph. Okay. Doesn't change my vertical asymptotes any. Okay, still the axis is the intercept of that middle axis is still the same. And so now when I plot the graph of the secant, I think I've incorporated everything. Double check me, you guys can't tell me right now, but I'll double check it myself. Period of 2, good. phase shift of -1, that looks good. Vertical shift up 4, that looks good. And amplitude +1, -1, that looks good. And the reflection, so it's upside down, that looks good. I think we've got everything factored in. Got my 5 key points in there. So now it's just a matter of changing it from the cosine to the secant. And we can do that. I like that middle section the best to start with. I know that because the negative cosine is above the x-axis, or the middle axis there, my secant graph is going to also be above. And so it goes up to the 2 vertical asymptotes. And then on the ends, because it's below, it's going to go down to those asymptotes. Okay, so this is going to look a little bit longer down there, but that works. And there they go. Cool. So that should give you an idea then of how to plot that graph. I think that covers all of the details. If I needed to plot this out farther, I could do so. I would just need to plot more vertical asymptotes, like at 3/2, because apparently the asymptotes are odd multiples of 1/2. So I could plot another vertical asymptote over here at 3/2, or at -3/2. And then I could continue, this graph would then continue with these kind of U shapes going down, and then another one would be coming up over here, and one up over here. And I'm just sketching those in rough, but you get the idea of how that would extend if we needed to extend to more periods. Okay. Cool. Well, I think that covers all the examples. At least that gets you some ideas of each of the different aspects. You got the secant and the cosecant examples so far. You've got examples with vertical shifts and horizontal shifts and reflections and periods and phase shifts. I did phase shifts, horizontal shifts. The period changes, reflections. Pretty much everything is incorporated in the last couple examples here. So